Hi everyone, pardon my voice this week. I'm getting over a head cold and so that's why my voice sounds like this. And that actually is a good transition to this week's topic, which includes failure mode and effect analysis as part of risk assessment. And so as you can tell, I definitely have a failure in my voice this week. The mode is the cold, the effect is this is what I sound like. So let's take a look at failure mode and effect analysis and what that can do as part of your risk assessment and management program. We'll use cheese as an example. Here's a basic failure mode and effect analysis table. So we've got the failure mode, what happens during the failure mode, the severity of the failure, how often the failure occurs, and how often the failure is detected, and the risk priority number. So for each failure, the severity, occurrence, and detection get scores of 1 to 10. 10 being this is a really bad problem. For severity, it happens all the time. For occurrence, and it's really hard to detect for detection. So as you can imagine, the higher those scores are for your severity, occurrence, and detection, the higher your risk priority number is going to be, because how you get that risk priority number is you multiply these three numbers together. So let's do an example with cheese. Now keep in mind, cheese is pretty complex. The process for making it is pretty complex. And so that means you can have a lot of failures. So there's no way I'm going through all the potential failure modes, how things fail for cheese here. I'll just do 3 examples. And also keep in mind that failures are not necessarily things that can hurt people. You have quality failures as well. So I have 3 different issues here that we're going to talk about: mold, metal, and rancid. Those are all failures, and the mode here is not the failure itself, but how that happens. So for failure mode for mold, we have poor sanitation. For failure mode for metal, we have, let's say, some kind of metal gets introduced into the process somewhere. There we go. And for rancid, rancid is caused by a lot of things, but generally you have too much lipase in your cheese from some kind of source, whether it's bacterial or a chemical source. That's what happens. Okay, so remember, our failure modes are not our failures. They're how the failures happen. So make sure you have that straight in your table, because, for example, our mold could be caused by poor sanitation, but it could also be caused by impure starter cultures. Maybe some mold got in there somehow. Maybe the mold is in packaging that comes in. It has nothing to do with our sanitation in our process. It actually came in on the packaging. So you have to keep all those failure modes in mind when you're looking at a particular outcome, which in this case is mold growth. All right. So our outcome for metal is metal in the cheese, and our outcome for too much lipase is a rancid flavor. And if you're thinking, well, what does rancid taste like in cheese? If you've ever had a really good, strong Romano cheese, imagine that flavor in cheddar. It's not exactly what you want in a cheddar cheese. It doesn't necessarily taste bad. Sometimes it can, but sometimes it just doesn't taste like cheddar cheese, so it does count as a failure. Now, we have to rank the severity, occurrence, and detection for each of these. So we'll go through, put these numbers in, and talk about that. In terms of poor sanitation, the severity of mold growth, it's not really going to make people sick. You're going to see that mold show up right away. It does cause waste, though. So I'm going to give this a severity of 3. For occurrence, poor sanitation causing mold growth doesn't happen terribly often, so I'm going to give this a 3 again. And detection of the problem, I'm actually going to push this number up a little bit, because you can't tell that mold is in the cheese until it's growing on the cheese and your product is ruined. And cheese typically doesn't get tested for mold spores. So it's hard to detect until that failure happens. Detection is talking about figuring out that failure before it occurs or just as it's occurring. Well, we can't really do that with mold growth in cheese. So I'm going to give this an 8. And that gives it a risk priority number of 3 times 3 times 8, which is 48. So, going over to metal in cheese. In terms of severity, that's a physical hazard in your cheese. It's something that, for example, a HACCP plan is designed to control. So that's pretty bad in terms of severity, but it's really not going to kill anybody. It might hurt them if they bite into that piece of metal, but it's not going to really, end somebody's life. So we'll give that a 7 in terms of severity. Occurrence, it doesn't happen terribly often. It's actually harder than you think it is to get metal into a process, at least on accident. So in terms of occurrence, we'll give that a 3 as well. And for detection, it's fairly easy to detect metal. Any standard metal detector will give you ferrous metal, and then if you've got an X-ray, you could detect even more types of metal, and you can even pick up things like glass and stones. So detection, will give that a 1. And so that gives us a risk priority number of 7 times 3 times 1, which is 21. Now for the rancidity, the severity. It's really not going to make people sick. It may make them a little bit grossed out. So in terms of severity, we'll give this, it's not even really as bad as mold because you can still eat the cheese. So we'll give this a 2. Occurrence, rancidity doesn't happen that often. It's actually pretty rare to find cheddar in the store that has gone rancid. It really has to sit around for a while under the right conditions. So we'll give this a 1. In terms of detection, it's pretty hard to detect rancid cheese without biting into it. And it's very hard to actually test for, is this going to have too much lipase in it eventually? Because remember, rancidity is something that happens over time. And you can't really tell, well, is this cheese going to be rancid or is it just going to have enough lipase in it to give me a little bit of extra flavor without pushing into the rancid zone? So since that's so hard to detect, we're going to give it a 10. And so that gives us a risk priority number of 2 times 1 times 10, which is 20. All right, so there's our 3 failure modes and our failures from those modes. And so if I had to pick one of these 3 to tackle first, I would tackle the mold because it's got the highest risk priority number, which means that it's going to have the worst outcome if this happens. Now, you may not want to rank things based on risk priority number. You may want to rank them based on the severity of things happen or some other factor in there. So if you've got something that you know is going to make people very, very sick or injure them badly, you probably want to tackle that problem first. On the other hand, that severity is generally going to give you a high risk priority number. So with those high severities, you end up with high risk priority number, and you're probably going to tackle it first anyway. But if we take a look here, the metal in cheese, that's pretty severe, but it's not nearly our highest risk priority number. It's more than twice as low as our top one, which is for mold. That's because we can detect it pretty easily. So those are some things you keep in mind when you do a failure mode and effect analysis is, okay, I've got this risk priority number. What do I want to tackle first? How easy is it to figure something out? How often does it happen? How severe is it when I'm going through and deciding what failures I need to attend to first? This is a pretty useful tool in general in industry. It may also be useful for your course projects. So take a look at your data and see if it lends itself to this type of analysis. If it doesn't, that's fine. If it does, that may be an extra tool that you can use to kind of sort out your problems, especially as you are implementing improvements and seeing, okay, are they working right or are they not? As always, any questions, feel free to shoot me an email or ask me questions on the course Facebook page.